Hi friends and welcome back. So I've got 10 really fun, moderately challenging, I want to say, maths questions for us to go through today. Let's see how many of these you could get. Let me know. So the first one is this. I've got 9 take 3 divided by a third plus 1. So we've got a sneaky fraction in there. Okay, so who's feeling up for the challenge? Do you reckon you could work this out? Let's do this together. So what we need to remember is BODMAS or BIMDAS or PIMDAS if you're American or British or Australian. It's funny how in different countries we use different acronyms, but the beautiful thing about maths, they say maths is the universal language. So anyway, how would we do this? So according to any of these acronyms, what we do, we look at our mathematical operation and we've got a subtract, a take away, a divide and a plus. So whenever you have that, you need to do the division part first. So we've got 3 divided by a third, okay? We need to work that out. So let's just write that over here. 3 divided by a third. Okay, I love dividing fractions. A lot of people hate fractions, but once you get used to them, just remember they're just numbers and they're pretty fun to deal with. So let's learn how to do this. No calculator. So 3 is just as a whole number. You can just say 3 on 1. And when you divide fractions, just remember this sneaky trick. You could just flip the second fraction around, and instead of the division, it becomes a multiplication. And then you could just do top times top over bottom times bottom. So 3 times 3 on 1 times 1, and 9 on 1 is just 9. Eventually, you're going to become so good at maths that you could probably do this in your head. Some of you may already be able to already. Okay, so let us now, so 3 divided by a third is 9, which makes sense. Like, how many times does a third go into 3? It goes 9 times. So we're going to replace this fella with this 9. So we still have, so be careful, we have lots of 9s now. So we've got 9 and take, and 3 divided by a third, we said is 9 plus 1. Okay, now it is nice and straightforward, my friends. When you've got subtraction and addition, you just go from left to right. So we just do 9 take 9, which is 0, 0 plus 1, which is 1. So your final answer should be 1. Great work if you got that. You're off to a great start. Hopefully you're able to follow that and that made sense. Okay, what about this? We're asked to solve the following question. Whenever we're asked to solve, they're basically asking us what is x for this to hold true. So what we want to do is isolate the x, and we need to do this step by step. So your first step is to move this 7 or to get rid of this 7. I like to think of it as moving it across the equal sign. Some people think of it as in order to get rid of this 7, you need to do the opposite. So you just subtract 7 from both sides. Same principle. Let's do the subtract 7 from both sides. So I'll write it up. So we're taking away 7 from both sides. That gets rid of that. And 19 take 7 is 12. So we could just say 3x. I should use the same color. Equals to 12. And we're nearly there. We have nearly isolated the x. We just want to get rid of that 3 that's in front of it. So it's 3 times x on our left-hand side. So in order to get rid of it, you need to divide. Whatever you do to one side, you have to do to the other side. So we're left with x over here. 12 divided by 3 is 4. So excellent if you were able to get that. Very good. Okay, this one. So again, we need to solve this, which just means figure out what x is. But this time, you'll notice that we've got our pronumeral, our x, on both sides of the equation. Okay, so it's a bit trickier, but it's not that bad. We've got this. So how do we do this? Well, the aim of this is to bring x's on one side and numbers on the other side. So I want to bring my x's to the left-hand side, and I can see that there's a 2x over here. So let's just bring it across. And we could do that in maths by bringing things across the equal sign, and it just becomes opposite. So it's a positive on that side. So when you bring it across, it becomes neg. And this -4 we want to bring across. So we have numbers on this side, and that will become a positive. It always goes behind the number. Okay, so we still have this 5x. So let's write that 5x, and now we brought that 2x across. So it becomes take 2x. And my right-hand side, we still have that 11, so we could write that. And then we brought that 4 across. Remember, change that sign, +4. 5x take 2x is 3x. 11 plus 4 is 15. And then what do we need to do? Just divide both sides by 3. And 15 divided by 3 is 5. Don't you just love it when maths just works out? And yeah, you get a nice, beautiful answer, and you just feel on top of the world. But yeah, well done. Hopefully you're feeling that, you got that right, or you're following through. Perfect. Okay, quadratics. So my favorite. This one's quite a nice, easy one. What we want to do again is solve this quadratic. So when you got a quadratic, sometimes you might want to solve it, sometimes you may need to factorize it, sometimes you need to graph it. So in this case, I want you to solve. In order to solve, it is easier to factorize it first, and then you can solve it. And to factorize a quadratic, you just write out all the multiples of your c, your last number. So multiples of 6 are just 1 and 6, 2 and 3. Okay, so this is interesting. You want the ones that add together to give you +5, but they need to multiply together to give you +6. So if they need to multiply to give you positive, they both have to be positive, or they both have to be negative. That's the only way they can multiply to give you positive. And so if they're both positive, these two would add together to give me 5 and multiply together to give me 6. So we know those two are my factors. So we could factorize my quadratic. So instead of writing x squared plus 5x plus 6, we could put my two brackets, put x and x because we get x squared, and then just write out my two factors. So you've got x plus 2, x plus 3. And so our quadratic can be factorized in that form. And using the null factor, so if you've got two numbers that multiply to give you 0, one of them has to equal to 0. So either our first factor equals to 0 or my second factor equals to 0. And if we rearrange this, you get x equals -2 or x equals to -3. Two solutions. So yes, you need both solutions for me to give you those marks, for this to be considered correct. Do give yourself partial marks. Be nice to yourself if you got one of those solutions, but ideally we want both. So good work if you got both of them. Pretty fun, right? Factorizing, and then we just solve. Beautiful. Okay, another quadratic, slightly harder. So we've got 2x squared minus 8x plus 5. And again, we're asked to solve this. Okay, so this one is a bit harder to factorize. So we're going to use my friend, the quadratic formula. So remember, any quadratic can be written in this form, which is what this quadratic is. And so a is just the number in front of your x squared term, which is 2. So let's write that out. B is whatever's in front of x. And just be careful of the sign. Do not forget the sign. So b, in this case, would be -8. And c is just your final value, which is 5, +5. So only the negative you put in the signs. The other ones, by default, we just assume they're positive. Okay, let's write out my beautiful quadratic formula. Minus b plus or minus square root of b squared, take 4ac all over 2a. There we go. And let's plug in our values. So we have, okay, be careful, we have negative b, and b is -8. So it's basically -8, and two negatives in maths make a positive, which we don't even need to write. So instead of writing -8, you could just write 8. plus or minus square root of, again, it's b squared. B was negative, and whenever you substitute in a negative value, try use brackets because it helps. It will help you with the sign. So b squared, I'll write negative 8 in brackets and then squared outside. Take 4, a is 2, c is 5, all over 2a. Okay, can we work this out? Yes, we can. So we've got 8 plus or minus square root of. Okay, neg 8 squared. So remember, that's just neg 8 times neg 8, which is positive 64. And then we've got minus, and then 4 times 2 times 5. 4 times 2 is 8. 8 times 5 is 40. So we have 64 take 40 under the square root, all over 4. And we could go further because we could work out what 64 take 40 is, which is 24 all over 4. Okay, can we go further? Of course we can. So let's think about the multiples of 24. So we have 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 doesn't go, and then 6 times 4. Are any of those square numbers? Well, the 4 is. So we're going to use those two. So remember, whenever you've got the square root and two things multiplied by each other, we could just break that up to square root of the first factor times the square root of the second factor. So what I mean by that is this square root of 24, we could just write as 4 times 6, because that's 24, and break that to root 4, root 6, okay? And the reason we do that is because square root of 4 is a nice value. It is 2. So basically, root 24, you could write as 2 root 6. That's what this was. And I like to show all my work in. You don't need to. You might be able to just do this in your head and go straight to 2 root 6. So we're just going to replace that with 2 root 6. So we still have 8. Then we've got plus or minus 2 root 6 on 4. Okay, and yes, we can go further. We could take out 2 as a factor, and that would leave me with 4 plus or minus root 6 on 4. And the reason I did that is because then you could simplify, because you've got 2 and 4, which becomes 1 and 2. So we have 4 plus root 6 on 2. Plus or minus, sorry, because we get 2 solutions. So 4 plus or minus root 6 on 2. So kind of a tricky one, but a fun one. You could also write that as 4 on 2, which is just 2, plus or minus root 6 on 2. So 2 plus or minus root 6 on 2. So either like that or like that. Either option is fine. Okay, well done. Well done if you're getting this far. We're halfway through. Hopefully you're having fun, you're learning, and that's what it's all about. So good work if you are watching this. I'm proud of you. It means you like maths, you're doing well. We've got to this stage. Okay, simultaneous equations. So we've got 2 equations here, and we're asked to solve again. So we've got y equals 2x plus 1 and 3x plus 2y equals 16. So there's a few ways you could solve simultaneous equations. The most common ones are substitution, elimination. Some people like to use matrices. You can even graph them. In this case, substitution is the easiest. And the reason you know substitution is the easiest is if you've got y equals to something or x equals to something, that means we could just substitute that into our second equation. So in my second equation, wherever I see y, I could just substitute this in because that's what y is. Okay, so what I'm doing is I'm going to replace the y with 2x plus 1. So let's just quickly write out what we're doing. Let's call this equation 1 and equation 2. We're subbing y equals to 2x plus 1, or we could just say we're subbing equation 1 into equation 2. So let me write out equation 2. So we've got 3x plus 2, and instead of y, I'm going to put this in and use brackets. So we have 2x plus 1. And remember, it equals to 16. So don't forget that part. That is a common mistake a lot of people do. They forget the whole equation. So now we got this, we could work this out. So you could just do 2 times this and then 2 times that. So we still have this 3x. 2 times 2x is 4x. 2 times 1 is 2. And that equals to 16. Okay, let's collect like terms. So you've got 3x plus 4x, which is 7x. So we've got 7x plus 2 equals to 16. Let's rearrange this. So we're going to get rid of this positive 2 by subtracting 2 from both sides. So we've got 7x equals to 16 take 2, which is 14. And then your final step, our favorite step, divide both sides by 7. And that gives me x equals to 2. 14 divided by 7 is 2. Are we done? Of course not. We need to work out what y is as well. So that's another thing a lot of students forget. So remember, simultaneous equations, you got 2 unknowns in this case, so we need 2 solutions. You need to know what x and y is. We could just substitute that back into our first equation. Y is 2x plus 1, and instead of x, we're going to substitute our 2 back in, and that's just 2 times 2 plus 1, which is 5. So my answer was x equals to 2, y equals to 5. So because they're xy, you can write these as coordinates. But yeah, don't forget both answers. Nice. Okay, let's shake it up a bit. Let's do a bit of trigonometry. So we've got a right angle triangle. We know that angle's 30 degrees. We're told the opposite. Let's label this opposite. Remember, the reason it's opposite is because whatever's opposite this angle is called the opposite. If it's got the right angle and the other angle, that's called my adjacent. And opposite the right angle, or the longer side, is always called my hypotenuse. So the key is just to label the side that you know and the side that you want to find out. So we've got opposite and hypotenuse, and the trig formula that has both opposite and hypotenuse is sine. So you've got sine theta is O over H, and we're going to plug in the values. Sine 30, that should say. Hopefully you can read my beautiful writing. Let's write that again. Sine 30 is my opposite, which is 5 over my hypotenuse, which is x. Okay, so this is another common mistake that students make. They don't really understand what's going on here, and they don't rearrange it properly. So what we need to do is make x the subject, and you can't bring what's on the numerator across. Not allowed. You could only work with the denominator. So we need to do this in 2 steps. You bring this x across over here first. So remember, it's a divide. When you bring it across, it becomes a times. And then you bring this sine 30 across there. So it's a times. So when you bring that across, it becomes divide. So a lot of people can jump from this step to that step, which is fine as long as you're doing the right maths, as long as you understand what's going on. Initially, while you're learning, feel free to write out the steps. It's a really good idea. So remember, when your unknown's on the bottom, it's a 2-step process. So my answer, my hypotenuse, is 5 divided by sine 30. And that is, you can actually do that in your head. Sine 30 is the exact value. It's a half. So we basically got 5 divided by a half. Let's write that out. 5 divided by a half. Remember, flip and multiply, which gives me 10. So nice, that was a good one. Do we have units? Centimeters, we do. So be careful, don't forget your units. Nice, feeling good? I hope so. But you should be. You've gotten this far, which is great. Not many students would have stuck around till here, so excellent work. I'm proud of you. Okay, a few more questions left. Let's see if you could get this. So if cos theta is 4 over 5, and we know that theta is a acute angle, it's less than 90, what's sine theta? Okay, so there's two ways I could think of doing this. We could use our identity, which is sine squared theta plus cos squared theta is 1, or we could just draw a triangle with a representation of what this is and see if we can work out the remaining sides. So let's do the second option because it sounds a lot easier. So remember, cos is just adjacent over hypotenuse. So if I draw my triangle, we say that's theta, that's our right angle, this is theta. So my adjacent is 4 because cos is adjacent over hypotenuse, and my hypotenuse would be 5. Is there a way we could work out this missing side? Let's call that question mark. And yes, there is. We could just use right angle Pythagoras' theorem. So we're working out a smaller side. So a squared is c squared take b squared. Let's label my diagram. Your hypotenuse is always called c. Our unknown, let's call that a, and we call that b. So it's basically 5 squared take 4 squared. That's what a squared is. So a would be the square root of that. 5 squared is 25. 4 squared is 16. 25 take 16 is 9. So we have square root of 9, which is 3. Beautiful. So we could just draw my triangle. We know all the sides now. So we know that's 4. We don't know what that angle is, but that's fine. We know that's 5, and we know that's 3. And then remember, the question actually asked us what sine theta is. And sine theta is opposite over hypotenuse. Your opposite is 3, and your hypotenuse is 5. So sine theta is 3 on 5. That was nice, right? That was hopefully quite a fun question. Quite easy to do as well. So hoping you follow that through. Okay, nearly there. What about this? Let's solve for x. So we're told that the square root of 3x plus 4 equals to 7. So how do we do this? Well, step 1 is we want to get rid of this square root. So we're going to square both sides. That gets rid of the square root. So you're left with, our left hand side is just 3x, 3x plus 4. My right hand side is 7 squared. 7 times 7 is 49. Now, this is quite easy. Bring the 4 across, so it becomes subtract 4. So you have 3x is 49 take 4. And 49 take 4 is just 45. And then remember, we just want x. So what do we need to do? Yep, we've done this a million times, so we're very good at this. Divide both sides by 3. 45 divided by 3, my friends, is 15. So x is 15. And usually when you get a question like solve and you're working out pro numeral, you could actually just plug that back in to here and see if it works. So 15 times 3 is 45. 45 plus 4 is 49. Square root of 49 is 7. So we know it works as well. So that's another beautiful thing about maths, is you could sometimes, and probably not even sometimes, more often than not, always check your answers. Okay, one last question. Find the limit as x approaches 2 for this. So we've got x squared, take 4 on x minus 2. So what happens as x approaches 2? Well, your first instinct might be just to put 2 for x. Okay, so it doesn't matter what the numerator is, but if you put 2 for x in the denominator, you have 2 take 2, which is 0, and then you have something divided by 0 in the denominator, which you can't do, it's infinite. So you can't substitute 2. But what else can we do? Can we factorize this? And we can. We've got 2 square numbers. So when you've got 2 square numbers, you could use difference of 2 squares, which would mean you have x minus 2, x plus 2 for the numerator. And then you still have x minus 2, and we want to know the limit as x approaches 2. But now it's nice and easy because that actually cancels. And remember, we want the limit as x approaches 2, and we're just left with x plus 2. And now you can sub in 2, so you have 2 plus 2, which is 4. So, excellent work for getting this far into this video. That's so good. Hopefully this is all making sense, you're having fun, and you've learned a bit of maths. Let me know how you went, and thank you for watching. I'll catch you next time.